All right, welcome everyone. This is 10.2 Similarity. Hope the first lesson and homework and quiz turned out all right. If you ever have questions, please email me. I'll do the best I can to get back to you quickly. You can also do a Google Meet where we can talk kind of face-to-face digitally, and we can even go over a problem if you need it. I've also, the principal said that students can actually come and get help if they need to, just can't be in big groups. So if you need to meet or want to come and get some help, just email me. We can talk about when we could do that. The rule, though, is that you can't do one-on-one. So I can't just have one of you come. You'd need to bring someone else to come, or if someone else, anyways, we'd have to figure that out if it came to that, okay? So again, do your best to watch the videos first. When you're doing the homework, there are hints in math space that you can click on. It's like a little light bulb. Sometimes there's videos that will help teach or review the concept when you're doing the problem. Okay, use those tools that you can. All right, so here we go. Let's get started. So I know that we've done these before, proportions. Okay, basically we have two fractions. They're the same, but they're proportional, but they're not like equal. So for example, 1/2 equals 1/2. Those are the same, but if we did like proportions would be something like 1/2 and 2/4, something like that. Those would be proportions. All right, so basically we have those set up, and we have one of the values is missing, and we just need to solve for that. So how we do that is we do cross multiplication. So we multiply 3x is equal to 8 times 8. It gives us 3x equals 64, and then we can just divide both sides by 3. So we just want to solve for x. On MathSpace, you can put your answers in as fractions like that, or you could enter it in as a decimal. It doesn't matter. You'll still get the right answer. Okay, so do another example. So 5n is equal to 2 times 6. That gives you 5n equals 12. And then we'll just divide both sides by 5. So n equals 12/5. All right. I probably won't do every problem on your notes. I don't want you to have too many videos you have to watch. But if you want more, I will make a second video that will go over those problems. All right. So let's talk about triangle similarity. Okay. Here we have two triangles, and let's first talk about looking at those two triangles. What are the corresponding angles? Okay, so corresponding angles means that they are, for angles, they have to be the same. So these symbols here, these little lines, like here we have 1 and 1, those are the corresponding angles. So angle A here is congruent to angle D. Here we have, for B, we have two lines, so the corresponding angle would be E. So angle B corresponds, or it's congruent to angle E. And then the last, where we have 3, we have angle C is congruent to angle F. Okay? So those are the corresponding angles. All right? Next question is, what are the corresponding sides? All right? So oftentimes you can just look at it very, very easily to see which sides are the corresponding sides just by the way they look. So oftentimes we can, there's lots of ways you could do it. We could say, well, the side that uses AB, okay, corresponds to this angle, okay? The angle, or sides, the angles that are right next to each other. So we have angle that has the 1 line and the 2 line. On the big triangle, we have the 1 line and the 2 line. Those are corresponding sides. Another way you could do that to figure out if it's corresponding sides, this is the way I like to do it the most, I think, is we just look, if we have the numbers available, you just want to look at the largest for the small and the largest for the big triangle. Those would be the corresponding sides. So corresponding side for AB, so side AB, and this is how you write it with a line on top. The corresponding or similar, sometimes we use this symbol, like a, maybe I didn't write that very well, but this symbol, I think I wrote it over here, it means is similar to, right? So side AB is similar to side DE. Okay, and then we could look at the next largest side for the small would be 7, and the next largest side here would be 14. So we have side AC is similar to side DF. And then we have the next side, the smallest sides, we have side BC is similar to side EF. Okay? If you wanted to prove that they are similar, you'd have to do proportions. So let me show you how to do that really quick. So if we wanted to prove that these two triangles are similar, okay, we'd need to come up with the proportions. So we'd have this side, since we said it, corresponding side would be this side, okay, we can make proportions. So we can do 10 divided by 20, right? And then we could do 7 divided by its corresponding side, so 7 over 14. And then our next one would be 6, and its corresponding side would be 12. So 6 over 12. If you notice, all of these are 1/2. Okay, they're the same fraction, they're just scaled differently. Okay, so since they're all equal to 1/2, then we know that those two triangles are similar. And we'll do more problems of that. Okay, so it says here, if two shapes are similar, that means that corresponding angles are congruent and corresponding sides are proportional. So this is what we did here. We proved that they are proportional. Okay, and again, this little squiggly line, that means is similar to. So it says identify corresponding sides and corresponding angles for each. They're telling us right here that they are similar. Okay, so we don't need to prove that they're similar. They're already telling us that they're similar, which means that the sides are proportional. All right, so this, what they wrote right here, this is called the Similarity Statement, and this will help us know which angles correspond and which sides correspond. All right, we're going to change this to maybe change this to an S so that we don't have the same letters. So right here, we'll say that's an S. All right, so this triangle QLM, sorry it's a little blurry, it says it's similar to triangle SQR. All right, and the order of those letters really matters. Okay, so here the first letter, these two letters, the first letter for both triangle, those are the same angles. These angles, if we notice right here, S and K, they both have that double line on it, telling us that they are congruent. Those two angles are congruent. So we have angle S, and it just says to write down, is it the pairs? Identify them, okay? So for corresponding angles are angle S and angle K, all right? And then we can look at, just by, you don't even really have to look at the triangle, L corresponds to Q, L corresponds to angle Q, and then the last one, angle M, corresponds to angle R. Okay? And again, you could look at the images or the triangles too, just kind of like we did before. Since the one has 2 and this one has 2, that those correspond. These have 3, those are corresponding, and these 2 are also corresponding. Okay, so different ways you could do it. Okay, and then we need to do sides. Okay, and this one will be really useful too to have this similarity statement. Okay, so they are also again in order. So if we're doing sides, KL, and we said this was an S, KL corresponds to SQ. Okay, and then we have LM corresponds to QR. And then the last would have QN, or KM, sorry, KM and SR. Okay, so we can find all this information fairly quickly just by looking at the similarity statement. Okay, so let's give this one a try. Maybe you try this one, pause and see if you can get it, and then we'll do that together. All right, so if we're doing angles corresponding, okay, and we know that those are corresponding angles are congruent. Okay, so maybe we'll write it this time as which angles are congruent. So here we have angle L is congruent to angle E, and then we do M and D. Angle M is congruent to angle D, and then the last would be angle N is congruent to angle C. And then we'll do our sides. So LM, so we'll do corresponding sides, and these are proportional. Okay, so LM is proportional or is similar to ED. And then we could do MN and DC. And then the last would be the LN and EC. Okay, so hopefully that was all right. Again, if you have questions, let me know. Okay, so and I wrote down these little numbers that kind of correspond to some of the, like here we have this 4, here we've got a 5. These kind of correspond to homework problems, so just keep that in mind too. All right, so it says, given that the two figures are similar, find the missing length. Okay, so if these are similar triangles, then the sides have to be proportional. Okay, and again, we did some proportions at the very beginning. Okay, so we're going to set up these proportions and solve for the missing side. Again, we have the similarity statement that will tell us what sides correspond to what. So, for example, UT, let me erase that first. UT corresponds to, here's UT, or TU, doesn't really matter. So we have, maybe we'll make this question mark be an X, is proportional to JK, and JK is right here, is 90. So we have one proportion. Next, we can choose, I guess we only have one other choice. We could do UV. So UV is 12 over, and then we'll find its corresponding side is KL. So that ends up giving us 54. So here they only give us two sides. You really probably could just look at it and say, well, this corresponds to this because they're both the biggest, and then these are the others. Okay. So either way, you could probably figure that out. But the similarity statement for sure tells you what's what. Okay. So we set up the proportions, and now we just need to solve. All right, so we'll just do the cross multiplication. So here we've got 90 times 12 is equal to x times 54. We can divide both sides by 54. And then we can just plug that into our calculator. All right, so 90 times 12 divided by 54, and that ends up giving you 20. So x equals 20. And like on like this math space, you'll need to plug in x equals 20, not just 20. All right, so let's give another try, or maybe pause and see if you can do this one by yourself. Okay, make sure you use the similarity statement. All right, so they're trying to find LU, which is this. So LU is x, and its corresponding side would be UW. UW is right here, so it'd be 98, is equal to, and then we're going to use our other proportions. So we'll do KU, be 18 over, and the other side, I guess that's the only other choice. You can use the similarity statement, and you'd find UT, or UV, gives you 84. And then cross multiply and solve. Okay? So we'd get x times 84 is equal to 18 times 98. And then we'll just divide both sides by 84. And we'd plug that in our calculator, and we'd get x is equal to 21. Okay? So here's one thing you need to make sure, be very careful. When we set up these proportions, we had this triangle is on the top, and this triangle we did on the bottom. Okay? So if we're going to do x over this, let me clear that out, it's a little messy. So if we're going to do this over this, then we need to do the same triangle on top of the other triangle. Okay? So same triangles on the top, and the other triangles all on the bottom. All right. Okay. Maybe I'll do one more, and if we need the extra practice, then you could see the other video. Okay, so here they want us to find this value here, x. Okay, these are two similar triangles. They just have them laid on top of each other. You're welcome to rewrite them so they're separate if it makes more sense. Okay, but we want to find this side. When they're on top of each other like that, we don't need similarity statement because they're like obviously, I guess they kind of need to say that these are like parallel or something like that. But we're just assuming that they are. Okay, so x and its corresponding side would be 20 is equal to, and they give us enough information that you could choose which other side of the triangle you want. So you could do big triangle over small, so 49 over 14. Okay, you could have used big triangle over small if you wanted to, again. So for this situation, we have our big triangle on top of the small triangle. And then we can just cross multiply. Really, you could just multiply both sides by 20. And you'd get x is equal to, and plug that into your calculator. That ends up giving you, well, let's see. 49 times 20 divided by 14 gives you 70. Okay? So, yeah, if you have any questions, let me know. There's some proportions. There's a lot of examples of scale factor. So let's talk about scale factor. You see I wrote down 2, 6, 7, and 8, so at least like 4 of the problems use scale factor. Okay, so scale factor, it's oftentimes written as K. I can't recall if that's what it calls it in math space or not, but we'll just call it K. Okay, so if K is greater than 1, there's enlargement. So you take some sort of shape that's maybe this big, you multiply it by K, and now it becomes bigger. So this is enlargement. Right? Reduction is when you take a shape and you multiply its sides by K, and it gives you a smaller shape. This is, again, is reduction. Okay, so to enlarge or reduce a shape, you multiply each side by the scale factor. Okay, so for example here, I changed this a little bit differently. If you are using the notes, then I just crossed these numbers out and changed it. Okay, so if K is 1/2, if the scale factor is 1/2, what is the dimensions of the new shape? So all you need to do is multiply the original picture or shape, or sometimes they call it the pre-image. You multiply it by its scale factor. So we would multiply everything by 1/2 to give us our new shape. So here we have our long side times, or multiply that by 1/2, so 28 times 0.5 or 1/2, that gives you 14. So we have 14, so it would also be 14. And then 1/2 of 20 would give us 10. Okay, so that's how you use the scale factor. You just multiply the sides by the scale factor to give us our new shape or image. Okay, sometimes they call this the pre-image, and this would be the image. But I don't think that will be on the test or anything. Okay. All right, so just here's some other ones. Here they're asking what is the scale factor. Okay, so to find the scale factor, again, the scale factor, or to use the scale factor, it's like the original shape times the scale factor gives us the new shape. Okay, so here, for example, if you wanted to find the scale factor, you just need to divide both sides by the original shape. Okay, and this really is just a proportion. Okay, so for example, if you wanted to find the scale factor, what do we need to multiply 14 by? We could maybe have it be K. What do we need to multiply 14 to give us 21? So we divide both sides by 14 and would end up getting K is equal to 3/2. Okay, and why I chose those numbers, perhaps you are asking. Okay, this obviously looks like this is the largest side. Okay, the next largest side would be 14, so that would be 21, and then the smallest side would be the 18. Okay, so it doesn't matter what sides you want to use. You could do 12 times the scale factor gives us 18. You divide both sides by 12, and that would still end up giving you 3/2. Okay, so maybe try this one, see if you can find the scale factor. So let's see, this looks like this is probably the largest side, and this is the largest side. So we just need to say, what do we need to multiply 120 by to give us 36? So here we divide both sides by 120. Okay, and that ends up giving you about 0.3. So that would be the scale factor. Okay, again, you could use this one. This corresponds to this one. That would give us 100 times K equals 30. So divide both sides by 100. And again, that ends up giving you 0.3. So again, it doesn't really matter. And you could make sure that you had the right scale factor by doing it twice at different sides, if that makes any sense. Okay? So those are scale factors. On these last problems, perhaps we'll do one example of that. Okay, I don't think this is on your homework, but okay. So we have these two triangles. Okay, we have a big triangle. Here's our big triangle. And then we have a smaller triangle. This didn't do that very well. Okay, and we want to find it's asking for this length. Okay, so here we have the big triangle. You could even say something like this is twice the size of this. Okay, so the scale factor to get from the big triangle to the small triangle, you would need to multiply it by 1/2. So all we need to do is do 10 times 1/2 will give us x. Okay, if you wanted to check this out, you could always say, well, this big side, we could say this could be, I don't know, this is length and this length. This line means that those are congruent. They're the same length. So the big triangle, this big length would be 2a's, and this would be 1a. Okay, and then we wanted to come up with the scale factor. You could do 2a times the scale factor is equal to a. And then we could divide both sides by 2a. That leaves us with k equals 1/2. Okay, so for all of these problems, the bigger triangle is twice the size of the smaller triangle, or you could say that the smaller triangle is half of the big triangle. All right, so here, if we wanted to find, this is 16 and we want to find this, well, that's just going to give us 8. Okay, here we have, this side is 9, the bigger triangle will be 18. Okay, and some of these, you would just need to realize that this, right, this, multiply this by 2, so 2 times x plus 17 would give us x plus 27. And we could solve the problem that way. Okay? All right, well, I think that's about it. If you have any questions, please let me know. So just remember scale factor, how to get that, how to set up proportions, and I think you'll be great. Okay, thanks.